Good morning students. I hope you all are fine and safe at home. This is Jyoti Nahar from Shiv Jyoti Educational Group, Kota, and today we will be doing chapter 5, separation of substances. The video part 1 has already been sent to you. In that video we have done the topics pure substances, types of mixtures, characteristic properties of mixtures and need for separation of two substances in a mixture and the methods of separation. In this we had done 4 methods of separation of solids, that is hand picking, threshing, winnowing and sieving. These 4 methods were discussed in our video part 1. Now in this video, that is video part 2, we will be discussing the topics sedimentation and decantation, filtration, evaporation and condensation, distillation and use of more than one method. In this we will be discussing the saturated solution and their properties. So students, let us start with the first topic, that is sedimentation and decantation. Now sedimentation is a process which is used to separate insoluble solid from a liquid. In this what do we do? The mixture of insoluble solids and water, it is allowed to stand for some time, and then the sediments, insoluble substances which are heavy, they settle down as sediments. And this process is called sedimentation. And when I pour out the clear liquid, when this clear liquid which is called supernatant liquid, the clear liquid which is just above the sediments are the particles which have settled down. These particles which have settled down are called sediments, and the clear liquid which floats on top is called the supernatant liquid. Now let us do it practically. See children, here I have a mixture of sand and water, and I have left it for some time so that the heavy sand particles, they have settled down. Here you can see in the mixture that the sand particles which were heavy, they have settled down, and so this clear liquid which is floating on top and is called the supernatant liquid, and these sand particles which have settled down are known as sediments. Now this process of leaving it undisturbed is called as sedimentation. Now what I am going to do is, I need to separate the clear liquid without disturbing the sand particles. I am going to pour out the clear liquid into another beaker without disturbing the sediments. See, I am able to separate water, and the sand particles which were left, which were heavy and has deposited as sediments, they are separated, and they have separated here as sediments. Now this rate of sedimentation can also be increased by using alum. This is a chemical substance which increases the rate of sedimentation. You can see children, this alum, when added, a pinch of alum is added to water which contains fine dust particles. When alum particles, they stick to the sand particles and thus makes them heavier, and so the sand particles settle down very easily. And now this substance, with this clear supernatant liquid which you call, it may have some impurities in it. As you can see, the water is still not crystal clear. So we need to do filtration now to remove some fine insoluble particles. We need to do the process of filtration. For filtration, I need a filter paper, and this filter paper can be folded in this way. In this way, we fold the filter paper and place it in a funnel that I am having here. This is a funnel. In this, I have placed a filter paper. I have already placed a filter paper. Now, I am going to pour out this liquid into the filter paper. And this is a very slow process. So children, this will take time, but you can see some sediments, some very fine particles which were not able to pass through the filter paper. They will be left behind in the filter paper and the clear liquid will be separated. And so this process by which we have filtered the water using the filter paper is known as filtration. So, I hope you have understood sedimentation, decantation and filtration. So, these are the processes which are used to remove insoluble impurities from water or any other liquid. So, children, you must have seen your mama when she cooks pulses or rice. Before cooking, what does she do? She takes it in a bowl and she puts water into it. The heavy the rice particles or the pulses, they settle down, and what does she do? She decants the clear water or removes the clear water without disturbing the rice particles. So, what is this process? This process is somewhat similar to sedimentation and decantation only, and the clear liquid is called the supernatant liquid, and the impurities or the particles which have heavy particles which have settled down are called sediments. And when we pour out the clear liquid into another container, that process is called decantation. Now, this process of filtration is in continuation, or we can say when the particles cannot be separated by sedimentation and decantation, we separate them by using filtration. In this, a filter paper is used, as I showed it to you. The materials or the mixture is allowed to pass through a filter paper, and the insoluble particles, they remain on top as residue, and the clear liquid which is obtained after filtration is called filtrate. Here you can see the clear liquid which is obtained after filtration is called filtrate. This clear liquid is known as filtrate, and the particles which have left behind on the filter paper, they are called as residue, and this clear water is called filtrate. So, this was about filtration. Now, you must have seen different types of different size of filters. They are used for different purposes, like we use a strainer to filter tea leaves from the brew, and a muslin cloth is used to filter tap water. You must have seen a muslin cloth which is commonly used to filter water at homes. So, different size of filters they are used, but it is very important that the size of the pores in the filter should be smaller than the solid particles to be separated. If the size is not smaller, the solid particles will come out of the pores. So, it is very essential that the size of the pores, they are smaller in comparison to the impurities. So, this was about filtration. Next topic. Now, students, we have internal question here, that is, in the first topic you are going to write the first internal question, that is in sedimentation and decantation. We have taken an internal question from page number 72. Page number 72, question number G, second part. Name the method used to separate a mixture of sand and water. This is the first internal question and the answer for this question is sedimentation. And the second internal question which we have in the topic filtration. This is again taken from page number 72. This question number G, third part, and the question is, after preparing tea, how can the tea leaves be separated from the brew? How do we separate the tea leaves from the brew? By using a strainer. So, the answer for the second internal question is with the help of a strainer. Now, we are going to write the third internal question just above our next topic, that is evaporation and condensation. The third internal question you are going to write on page number 67, children. The third internal question is again taken from page number 72, back exercise. Question number G, fourth part. You have to write the question, which method is employed to collect salt from seawater? This is our third internal question and the answer for this question is evaporation. So, we are going to understand this process of evaporation with the help of a simple video. So, students, evaporation can be understood better by the help of this video. Evaporation is a process when the liquid converts into gaseous state on gentle heating and it converts into vapors, and this such that the liquid does not boil, and this process is called evaporation. Let us understand this. Taking a salt, and if we dissolve salt in water, you can see here when we add a pinch of salt into water, the salt completely dissolves in the liquid and we are not able to see the particles of salt. Now, when this solution of salt and water, it is left overnight or for a longer period of time, the water converts into vapors and this salt is left behind. So, this is a way of separating soluble solids from liquids. This is a simple and very easy method by which we can separate soluble salts from water or any other liquid. Now, if this salt, the salt that is left behind is separated, and this process of evaporation can be increased by heating the liquid. If we heat the liquid or the water, it converts into vapors and the salt that is left behind is obtained as and separated. Now, what is evaporation? Evaporation is the process of converting water into water vapors on heating. So, this is the process of evaporation, students. You have already learnt in the earlier classes. Okay? So, this process is basically used for separating the substances which are soluble in water, and this process evaporation is also used to separate salt from seawater. As you can see, the seawater is allowed to stand in shallow pits. Here you can see the shallow pits. In these the seawater which contains a mixture of salts is allowed to stand in pits, and when these pits they are undergoing sun's rays, the water evaporates due to the sun's heat, and what is left behind is salt, and the salt is obtained. The salt so obtained can be purified further to get salt that we use in our homes, in our kitchens daily. Okay? So, you have understood the process of evaporation. Okay, students. Now we are going to do the process of condensation. Now, what is condensation? You have already learnt in your earlier classes, students. What is condensation? Condensation is the process of converting water vapors into water on cooling. Let us see how this takes place. We are going to do condensation. What happens in condensation? Suppose I have a glass which contains hot water inside it, and I have covered this hot water with a plate, but this plate is cool as compared to the water inside it. After some time, what do you observe? That some water droplets, they condense on the inner surface of the plate. Why did this happen? This water, when it was hot, the vapors which rose up, they came in contact with this plate, and this plate, as it was cooler than this water, so the water vapors, they have turned back into water, and this process, when water vapors, they turn into water on cooling. This is a important condition here. On cooling, these water vapors, they convert into water, and this process is known as condensation. Okay, students. So, this was about condensation. Now, we have another topic here, sublimation. Sublimation means some solids like ammonium chloride, iodine or camphor, they directly convert to vapor state. Means from solid state, they directly convert into the vapor state, and these substances which directly convert into their vapor state, they are known as sublimates, and the process of conversion is called sublimation. Okay, students. So, you have understood evaporation, condensation and sublimation. Now, let us take up the next topic, distillation, from page number 68. Okay, students, distillation, it is a process of separating a liquid from soluble salt solution. Here we can understand distillation with the help of this diagram. What we are doing is, first we allow the liquid to evaporate. First evaporation is done, and then condensation is done with the help of condenser. Here you can see, this is the process which is showing distillation. Here we have taken a round bottom flask. In this we have this mixture of soluble salt solution, and this it is heated, and when the vapors, they rise up, these vapors, when they rise up, they are allowed to pass through this condenser. This is a condenser over here which converts these water vapors into water again, and this water is, when it passes through condenser, it is then collected in another round bottom flask, and the water which is obtained after this distillation process is known as distilled water. This is the purest form of water. We can call it distilled liquid or distillate. And this process which we are using, where first evaporation is done and after that recondensation of the vapors is done, is known as distillation. Now, the next topic that we have here is, this is a method which we can use to separate soluble salt solution by evaporation, and then we recondense it. Next topic that we have here is magnetic separation. Now, in a magnetic separation, an electromagnet is used. We separate magnetic substances from scrap material. We can separate the magnetic substances like iron filings. They can be separated by using a large electromagnet. This electromagnet, when it comes in contact with scrap, all the magnetic particles, they get attracted towards the electromagnet, and then it is removed, and as soon as the current is switched off, the iron filings or the magnetic materials, they are separated out into another heap. So, this is a method where we use an electromagnet to separate the magnetic substances using magnetic separation. Now, our next topic is separation of liquids by using a separating funnel. Here students, you can see that a separating funnel is there, and this method is used to separate two miscible liquids. This method is used to separate two immiscible liquids. Two immiscible liquids, between these, one is heavier and the other one is lighter. The heavy liquid, it remains in the funnel, separating funnel, and the lighter one will float on top. Like if I take a mixture of water and oil, oil is lighter and so it will float on top of water. When this stopcock, I have a stopcock which is in the separating funnel, when the liquid is allowed to run through this, when we open up this stopcock, the liquid which is below it is allowed to flow out and it separates, and when the layer of oil comes, we immediately shut down this stopcock, and so in this way we are able to separate heavier liquid from a lighter liquid by using a separating funnel. Now, next topic children, here we have use of more than one method of separation. This is on page number 69. Let us take up this topic. Now, sometimes what happens, you have to follow more than one method of separation to separate out the substances. Like if I have iron filings and sand and salt, I need to make sure that I have used more than two methods to separate iron filings. I need a separate method, and to separate sand and salt I need some other method. So, sometimes we need to use more than one method of separation. Supposing I have a mixture of sand, salt and water. Now children, can you think how will we separate these three substances? For separating these three substances, we need to do more than one method of separation. Like for sand, how will we separate out sand? As we did earlier, as I showed it to you practically, that sand, it can be separated by using sedimentation. First, we are going to do sedimentation. In this, sand will settle down and salt is soluble in water. So, salt remains separate with water. Then we are going to do the second process, that is decantation. When decantation will be done, sand particles, they will remain in another beaker and I will get salt and water in separate beaker. This, instead of doing these two processes, we can also use filtration over here. Okay students, filtration is a very simple method, but sometimes when sedimentation and decantation cannot be done, we use filtration. Now after separating out the sand, what do we have? We have a solution of salt and water. Now how do we separate salt and water? As we have discussed earlier, salt and water, they can be separated by the process of evaporation. This solution, when kept in sun, the water will evaporate due to the heat of the sun, and what will be left behind? Salt. So by following these three processes, what have we done? We have separated sand, salt and water into three different categories. So this is an example where we are using more than one method of separation. Similarly, if I have iron fillings, sand and salt, I am going to use, first we are going to use the magnetic separation method, and then these two processes will be done in continuation. So students, this was about using more than one method of separation. Now you must be wondering, now you must be thinking, like, can water dissolve any substance or any amount of substance? Can it dissolve all the substances? Yes, the answer is yes. Water is called the universal solvent. Why is it called the universal solvent? Because it dissolves most of the materials. Most of the materials are soluble in water, and that is why we call water as universal solvent. Water is called as universal solvent because most of the substances are soluble in water. Now, if more of the substance is added, sometimes what do you observe? When we add the substance, it dissolves. On adding more and more of the substances, the substance stops dissolving. Have you ever noticed that? Like, take for example, we have a glass of water. In this, I am adding a spoonful of sugar. When I add sugar into it, what will happen? It will dissolve in water. A soluble substance will, it is soluble in water, and so we will get a homogeneous mixture. Again, if I add one more spoonful of sugar into it, it will again dissolve into it. If I again add one more, then this method or the solubility will decrease. The time taken to dissolve this third spoonful of sugar will be more. If I keep on adding more and more of sugar, a condition will be reached, or you will reach one condition, or at a moment of time you will notice that no more of sugar gets soluble or dissolves in this mixture. And this mixture, which dissolves no more of the solute, is known as saturated solution. What is saturated solution? Saturated solution is that solution which dissolves no more of the solute, means on adding of solute, on adding more of solute, the solute does not get dissolved in it. That substance is known as saturated solution. So these were the important topics of our chapter, students. We have discussed the different methods of separation and the solubility in water, which increases due to heating. If I heat the substance, the dissolving power may increase, the substance may increase or may dissolve, but that will again come to a point where the substance will become saturated. So, we have done all the topics of separation of methods. I hope you have understood the topics that we have discussed, and practically you can do the experiment too that I showed you. I hope you have watched video part 1. Now go through this video. I hope all the topics are clear in this video. Thank you students.